Hi guys, welcome to this lesson. In this lesson, I'll be taking you through irrational numbers. In our previous lessons, we've looked at natural numbers, we've looked at whole numbers, so we've looked at natural numbers, whole numbers, integers, ratio numbers, and now we are looking at irrational numbers, which will bring us to the bigger set, real numbers. So over the years and for a long period of time, people believe that every number can be represented as a fraction. So people believe that every number can be represented as a fraction. Until there were some few exceptions that changed the minds of people. So irrational numbers are simply numbers that cannot be fractions. That's all. So if I have a number and I cannot represent it in the form P over Q, so that P and Q are a member of what? Integers Z. Then I will say that where Q is not equal to 0, then I'll say that this number is said to be what? Irrational. If I cannot change a number to a fraction, then it's irrational. Or if a number is in the decimal representation, and it's neither terminates. So look at the condition. So if it's neither terminates or recur, then I can say that this number is not irrational. So these are the two main conditions for a number to be rational. One, cannot be represented as a fraction. Number two, even if it is represented as a fraction, if the decimal representation is neither terminating or is recurring, then I will say that this number is irrational, right? Yes. Now, irrational numbers do not have any special symbol, unlike the others. Why? Because it's irrational. They are so interesting. So it has this representation generally accepted that we have R, which is a set of real numbers, slash Q, which is rational numbers. So the definition of this is that if I have real numbers and I take away my rational numbers, the rest is what? Irrational. So this is just a simple funny representation of irrational numbers, right? Yeah. So in this lesson, I'll show you some common irrational numbers and some few properties we have for this here. So for every irrational numbers here, we have some famous irrational numbers we can talk about. We have what we call the um, geometry. In geometry, we have square root of 2, we have square root of 3, we have square root of 4, right? We have square root of 5. So all these are irrational numbers. You realize that you cannot represent this as a fraction. So square root of 5, you cannot represent this as a fraction. And also the decimal for this, when you punch this into the calculator, you realize that it gives very discontinuous values. All of them are distinct and it doesn't have a pattern, neither repeating or recurring, or neither terminating or recurring. So this makes all radicals, right? Radicals of primes mostly, but um, an irrational numbers. Let me say it that way. Now, in circles, we have this beautiful number called pi, right? So in circles, we have this number called pi or pi. So now pi has a very long value and it doesn't end. That is why, despite the fact that it is 22 over 7, it's still considered as what? Irrational. Okay, it's still considered as irrational. So pi is irrational because it doesn't end. Its decimal part doesn't end. Okay, now we also have some few things we can talk about. And the last infamous irrational number is what we call the e. That is in calculus. So in calculus, you realize that we have e to the power this, e to the power that. E is also an irrational number because it cannot be represented as a fraction. So take note. Now, you realize that irrational numbers, as we've been talking about numbers, the closure property, irrational numbers are not closed. Take note. Please take note. So irrational numbers, they are not closed anywhere. So irrational numbers are not closed. Numbers are not closed. And interestingly, they are not even closed on addition. Why? So in addition, if I have square root of 2 and I add it to negative square root of 2, what do I get? I get 0. 0 is not an irrational number, right? My result is simply what? A rational number. So meaning it's not closed even under addition. In multiplication, if I have square root of 2 and I multiply by square root of 2, what do I get? I get 2. And that is also not irrational number. So irrational numbers are generally not closed, totally not closed. Okay. Then also you realize that when an irrational number, when you add an irrational number to an irrational number, as we talk about here, we don't get an irrational number. When you multiply an irrational number by a rational number, so irrational times rational, they usually gives irrational. So mostly it gives irrational. So get to know this pattern because it mostly appears in OBJ. So in algebra, you'll be seeing this in the objectives. The irrational number times rational gives us irrational. That is 2. Square root of 2 times what? 2 will surely give me 2 root 2, which is irrational number. Right. Yeah. So irrational numbers also exhibit the density property, so that between any two rational numbers you have dense. And in fact, when you talk about the evolution of numbers, you realize that integers realize something interesting, that integers were space. Sorry, yes, integers were space, natural numbers were space. We have whole numbers, they were also space, so that they are discrete. If I have 1, I move to 2, I move to 3. If I have integers -3, I move to -2. They were not in between, they were just spaced. When you came to rational numbers, you realize that in between these two we can have fractions and all that. But irrational numbers fill the rest of the gaps. So if a number is not is not rational, then the number is what? Irrational. That is why when you combine rational, let me use a symbol. When I combine Q and union, let's say my R slash my Q, I mean that's representation, then this should give me every possible number on earth. So as it stands now, I don't know if anyone can still bring a different number concept, and that would be very beautiful, because combining irrational plus rational has been able to cover every particular number or every possible number you can think about in this world. Yeah, so this is the concept of irrational numbers, and I've just shown you how to identify if a number is irrational. It doesn't have a terminating or recurring decimal, and neither can it be represented in the form P over Q, where Q is not equal to 0. Thank you for being with me in this video, and please stay glued to your seat and follow this course. Don't forget to subscribe as we move through all these lessons, and you'll be solving more problems as we move along.